Hi everyone, here's your pre-lab exercise for experiment 2, which is Le Chatelier's principle. So the question 1, a system at equilibrium or striving to reach equilibrium respond in a way that best accommodates or reduces any stress placed upon it. In chemistry, what is a statement above known as? This is the Auerbach principle. Remember the Auerbach principle we learned in General Chemistry 1, which is how the electrons are filled up in the orbitals based on the energy levels. So in basically Auerbach principle says the lower energy levels, the lower orbitals fill first, and then as the energy increases, the electrons are filled in that order. So it's not the Auerbach principle. What is the Heisenberg uncertainty principle? Again, you learn that in General Chemistry 1, which is you cannot find the position and the momentum of a electron at the same time. So if you find the position, then it has to be still. So the momentum will not be accurately calculated. So the position and then the momentum or the speed of an electron cannot be measured at the same time. That's the Heisenberg uncertainty principle. And Le Chatelier's principle. So what is the Le Chatelier's principle? That is what the principle that we talked about. If a system is at equilibrium or striving to reach equilibrium, it responds in a way that best accommodates or reduces any stress placed upon it. Okay, so that is the Le Chatelier's principle. And law of mass action also, you know, the reactant mass of the reactants are going to be equal to the mass of the products. So the correct answer is Le Chatelier's principle. Question number 2. Solution of acetic acid is allowed to come to equilibrium. Acetic acid with water, it is a weak acid, so we have the reversible arrow. It forms hydronium ions and acetate ions. If some silver ion is added to this solution, the insoluble solid silver acetate is formed. After addition of silver, the resulting amount of undissociated acetic acid in the solution would be. Now, let's see what is happening to our equilibrium when we add silver. So it says when you add the silver ion, so you add silver ion, okay, and then we have it's going to form solid silver acetate. How is it going to form the silver acetate? So silver is going to basically react with acetate ion, CH3COO minus, so that is acetate. So silver ion react with acetate. What is it going to form? So it basically going to react with one of the products and form silver acetate. Okay, silver acetate. By adding silver, what is happening to our one of the products? Acetate. This acetate is going to react with silver. So basically what we do is we're going to reduce the amount of acetate in the solution. Basically what we are doing is we are disturbing the equilibrium of the system. So if the system is disturbing by removing the one of the products, how do you think system would now behave? What does it need to do? Because now the acetate ions are being removed from the solution, the more of the acetic acid, one of the reactant will start dissociating more. Okay, because now we are losing one of the product, so then the reactant will start compensate that loss. So it's going to produce more of the acetate ions by dissociating more of the acetic acid, which is the reactant. Unchanged from that in the original solution, higher than that in the original solution, lower than that in the original solution, and 0. What do you think? What is going to happen to the acetic acid concentration? The resulting amount of undissociated acetic acid in the solution would be lower than in the original solution. Why? Because now the acetic acid is losing, not acetic acid, acetate ion. So acetate ions are losing. So as a result, what's going to happen is more of this is going to dissociate. More of, why it's not writing? It's not that dark. Okay, so more of that is going to dissociate. So the acetic ion, acetic acid ion, the undissociated ion would be less than the original solution. Excuse me. Okay. Okay, so the next one, methyl orange. Methyl orange HMO is a common acid-base indicator. In solution, it ionizes according to the equation. HMO, it dissociates to give you H plus ions and MO minus. HMO is red, so this one is red in color. And MO minus is yellow in color. Okay, so that is yellow color. This one is yellow. This is yellow. And then this one is red. If methyl orange is added to distilled water, the solution turns yellow. So in deionized water, so solution is yellow. This one over here. Excuse me. What will happen to the color if a few drops of HCl are added to this yellow solution? What are we doing here? We are adding H plus. Okay, so then we have more of H plus. When you add H plus, which direction do you think the reaction will proceed? Is it gonna keep moving to the forward direction, or is it gonna go back to the reactants? If you add H plus, we are adding one of the products, right? So the products now are going to be increasing. So since we add more of H plus, so then the reaction will move towards reactant side to get rid of the added H plus ions. Okay, so basically the reaction will become now red. The color will become darker yellow, the solution will turn red. So the second choice, the solution will turn red because added H plus react with MO minus to form the red HMO. Okay, so the solution will turn red. So that is how the Le Chatelier's principle works. If you add one of the reactants, so then to compensate that added reactants, it would proceed to making more of the products. If you add one of the products, in this case H plus is a product, so then the products will react together to form more of the reactants. So then it would not increase too much of the products in the right side. Okay, so that's how the Le Chatelier's principle works. So the solution will turn red. Okay, now the third one is, we did third one. So the fourth one, when methyl orange is added to a strongly acidic solution, the indicator turns red. Okay, what will happen to the color if 6 molar sodium hydroxide is added to this red solution? See question 3 for the relevant chemical equation. So our chemical equation is this one. Okay, HMO dissociate to give you H plus and MO minus. Now we have a methyl orange, a red color solution. What will happen to the color if 6 molar sodium hydroxide is added to this red solution? What do you think is going to happen? When you add sodium hydroxide, what do you think? So we are adding a base, hydroxide ions. What are our choices? The color will become darker yellow. What do you think? Would the color become darker yellow? because added H plus will cause more MO minus to form. The solution will turn red because the added H plus react with MO minus to form the red HMO. No color change will evident. Oh no, I'm just looking at question 3. Question 4. Wait. Alright, let's see the choices for question 4. The red solution turns yellow. The added OH minus react with H plus, shifting the equilibrium equation 3 to the right. The red solution become a darker red color. The added OH minus react with H plus, so the equilibrium equation 3 shift left. No color change will be evident. The solution remains red, but the color is less intense is the added sodium hydroxide. Dilutes the solution without changing the position of the equilibrium described in question 3. So what do you guys think? What happened? When you add hydroxide ion, what's going to happen? Now when you add hydroxide ion, so let me go ahead and draw the equation. We have HMO, H plus plus MO minus. So you are adding, so this is red and this is yellow. Okay. So when you add hydroxide ions going to react with the H plus, this H plus, and form water. So as a result, we are removing H plus from the system. We are removing this one. It's gonna go low. So as the hydrogen ion concentration goes low, what is going to happen to the equilibrium? Which direction do you think it should shift? It will start making more of the products because now the H plus is leaving the system. So you want to bring it back to the equilibrium. So the reactants will start forming more of the products. So as a result, red color will start forming yellow. Okay, so when you add hydroxide ions, the red solution turns yellow. The added hydroxide react with H plus, shifting the equilibrium in question 3 to the right. So the correct answer would be the first one. The red solution turns yellow. Okay. Question 5. For an exothermic reaction, what will happen to the numerical value of Kc if the temperature is increased at constant pressure? For exothermic reaction. So for what is an exothermic reaction? In an exothermic reaction, let's say you have A giving you a product B. And you can also consider heat as a reactant or a product. In an exothermic reaction, where do you find the heat? Heat is a product. Okay. So this is what is happening in exothermic reaction. A forming B product and it removes heat. So heat is a product. What will happen to the numerical value of Kc if the temperature is increased? So this is in equilibrium. So you increase the temperature, meaning you are increasing one of the product. So then what will happen? So you know Kc is the product concentration over reactant concentration. Now if you increase heat, what's going to happen? You are increasing one of the product. So then your reaction should shift to the reactants. So then the amount of A increases. A would increase, so then the B would decrease. If B become a lower value and A become a higher value, what's going to happen to the Kc? Kc will become low. So Kc will decrease. Okay. So then the Kc will decrease. Okay. Next one, consider the following reaction. Now we have in this one silver sulfate. Silver sulfate is a solid. It dissociates to give you silver ions and sulfate ions. And for this one, delta H is given as positive 18.8. When the delta H is positive, what does that mean? Is it exothermic or endothermic? It is an endothermic reaction. Delta H is positive. If the delta H is negative, that is an exothermic reaction. So in this particular reaction, we find heat is a reactant because it's endothermic and if you add heat, heat is going to consider as a reactant. Now, consider the following reaction. The reaction can be shifted to the right. So we want to shift the reaction to the right. What do we need to do? Adding aqueous silver nitrate. What happens if you add silver nitrate? We want the reaction can be shifted to the right by adding more silver nitrate. So silver nitrate is a strong electrolyte, silver nitrate. It is going to dissociate into silver ions and nitrate ions. So we are adding more of the silver ions to this solution if you add silver nitrate, meaning we are adding more of the one of the products. So if you have more of the products, what's going to happen? Is it going to go the reaction towards the right side, or these added silver ions combine with sulfate to make more of the silver sulfate? So by adding silver nitrate, it would make reaction go more towards the reactants. So it would, meaning it goes to the left side, not the right side. Okay. What about adding sulfuric acid? Same thing. Sulfuric acid is also strong acid, dissociate 100% to hydrogen ions and sulfate ions. Sulfate ions, again sulfate ion here is one of the products, so you adding more product, then equilibrium will shift to the left side. That is not going to help either. Lowering the temperature. What's going to happen if you lower the temperature? If you lower the temperature, heat is a reactant, right? So heat is a reactant. So if you lower the reactant, lower the temperature, then again the reaction will shift to the left side, because left side is where we have the heat. If you lower it, then the reaction equilibrium will shift to making more of the reactants, because when you make the reactants, then only you can form more of the heat. Okay, if you lower one of the reactants, so then equilibrium will again shift to the left side. So that's not going to work either. And then evaporating some of the water to make the solution more concentrated. If you evaporate to make it more concentrated, if you have more of the silver and the sulfate ions, so then there are more of those number of moles, again that will shift to the left side, making more of the silver sulfate. Diluting the solution by adding water, making it less concentrated. Now we are making silver ions and sulfate ions. So these silver ions and sulfate ions less concentrated. So you have less of those. So when it is less amount, so then more of the silver sulfate will start dissociating to form more of the silver ion and the sulfate ions. Okay. Anything which decrease the concentration of one or both products will shift the equilibrium to the right. Okay, so basically by diluting the solution, by adding water, we'll make it go to the product side. Excuse me. Number 7. Zinc hydroxide is only very slightly soluble in water. Excuse me. The reaction by which it goes into solution is given in this equation. Zinc hydroxide solid forming zinc ion and hydroxide ions. What is the expression for the equilibrium constant? Ksp. Ksp is basically solubility product. You know how to write the Ksp. Ksp is going to be concentration of the products over the reactants. So our products are going to be zinc 2 plus. There are no coefficient at the beginning, so just leave it like that. And then the hydroxide, there are 2 hydroxides, so I have to raise it to the power 2. And zinc hydroxide concentration. Okay, so now these two are aqueous. Now for the Ksp, do you normally write solids in Ksp, solid concentration? You don't, right? Because here zinc sulfate is a solid. Solid reactants or the products normally do not go to your Ksp expression. So this part you're not gonna write. Okay. only that much. Next one, question number 8. How will the solubility of zinc hydroxide change if zinc hydroxide is placed in a solution of zinc chloride rather than in distilled water? What's going to happen to the solubility? Let's say you're adding zinc chloride. So zinc chloride again is a strong electrolyte. It will dissociate to give you zinc chloride, will give you zinc ions and chloride. So zinc hydroxide, we're going to look at what is going to happen to that solubility. So zinc hydroxide will dissociate to give you zinc ions and hydroxide ions. Now this is the equilibrium we are looking at, and you add zinc chloride. So by adding zinc chloride, you are adding zinc ions to the solution, meaning you are making more of one of the products. So as you increase the product, what's going to happen? Then it will decrease the solubility of zinc hydroxide, right? But if you just put it into distilled water, now we are making a solution more diluted. As you make the solution more diluted, zinc ions and the hydroxide ions will become less. So then zinc hydroxide can dissociate more. But if you add zinc chloride, since zinc is one of the products, so then it will move towards forming more of the reactants, making the solubility of the zinc hydroxide decrease. Okay, so the answer would be solubility will decrease compared to the solubility in distilled water. Okay, did you get it? Again, the zinc chloride is a strong electrolyte which dissociate to yield zinc ions and chloride ions, and then by diluting it to distilled water will make solubility more. Zinc hydroxide to be soluble more. Okay, and then the next one is similar to this. Okay, question number 9. Question number 9. I'm going to erase all this here because I wrote everywhere. Oops. Hold on. Okay, question number 9. How will the solubility of zinc hydroxide in 1 mole HCl compare to solubility of zinc hydroxide in distilled water when you add hydrochloric acid? Now let's look at that. Now we have zinc hydroxide again. It's going to dissociate to give you zinc ion 2 plus and 2 hydroxide ions. And you add hydrochloric acid, H plus. Hydrochloric acid is a strong electrolyte, gives you H plus and Cl minus. So this H plus that we added going to react with hydroxide ions. Hydroxide ions, that is going to be it's going to form water. When you add H plus hydroxide ion in your solution, hydroxide ions, which is one of the products, going to remove from the solution, zinc hydroxide. So as the hydroxide level goes down, what's going to happen? It will start dissociating more of the zinc hydroxide, forming more of the products. So then the solubility will increase. The solubility will be greater. Okay. H plus produced via dissociation of HCl will react with hydroxide, and hydroxide is one of the products. So as the product concentration lowers, so it will start forming more of the products by decreasing the amount of zinc hydroxide, meaning it will increase the solubility. The solubility will be greater. Okay. Question number 10. Consider an aqueous solution in which the following 3 equilibria are operating. Silver bromide dissociate to give you silver ion and bromide. And then the silver ion in the presence of S2O3 thiosulfate, it's going to form silver thiosulfate. Okay, and this thiosulfate ion again in the presence of acid can give you thiosulfite plus water. Which suggested change will increase the solubility of silver bromide in the solution. Okay, so we're going to look at which one will help us to increase the solubility of silver bromide. Silver bromide. How can we make it increase? Add the soluble salt sodium thiosulfate, Na2S2O3. Sodium thiosulfate again is going to be a strong electrolyte. So the strong electrolyte, it will give you, this will give you Na2 plus, Na plus, Na plus, Na plus, S2O3, 2 minus, strong electrolyte. So what's going to happen when you add a strong electrolyte? You find it here, S2O3, right? S2O3, the more S2O3 you have, it's going to react with hydronium ion. So the more S2O3 ion reacts, what's going to happen? So then the formation of this compound increases. So the silver ion, so when you add more of the thiosulfate, the silver ion going to react with this one and form silver thiosulfate. As the silver ion is going to remove from the solutions, because silver coming from here, so we are reducing silver ion in this system because now silver ion going to react with the added thiosulfate. So as a result, the solubility of silver bromide will increase. Solubility of silver bromide increases. So by adding the soluble salt sodium sulfate, the solubility of silver bromide increases. Okay. Add concentrated hydrochloric acid, which will increase the concentration of hydronium ions. Add more silver bromide, add the soluble salt potassium bromide. None of these changes will do a thing. Okay. So basically the solubility of the silver bromide solid will increase if the concentration of silver and bromide decreases. See, if the silver ions and the bromide ions, if the amounts of these two decreases, so then we can increase the solubility. And that can be done by adding salt sodium thiosulfate, because we know that silver ion directly react with thiosulfate. So we are removing the silver ions. As a result, silver bromide solubility increases. Okay. All right. So that's about it. Okay, then I'll talk to you later. Bye.